better programs. So this talk is about understanding everything that happens behind the scenes of your web framework. So let me start with discussing between the internet and the World Wide Web. So is there a difference between internet and World Wide Web? Ari? So can someone answer me what's the difference between the internet and World Wide Web? Thank you so much. Protocol, the key thing about the web is URLs. Okay, so what make World Wide Web really unique, it's really powerful is you can identify any resource anywhere in the world with a simple unique string. Okay, everything in the world can get a unique string that you can represent with. Okay, you have an image, you have a document, you have anything. Okay, you can just represent it with a unique string that's called a URL, uniform resource locator. Okay, so that's a URL. Okay, so now how it works is so curl is a program that actually used to request something just like your browser, but what you're using from the command line to request something. Let's me pin.org. So you're making a HTTP request to web page, so that responds back with some response here. Okay, now so let's try to actually understand what how actually response works. Okay, so with the V it actually shows what actually going behind the scenes. So if making a request to HTTP bin/get. So what happens is, just like we have seen in the email protocol, what it does is it actually sends a request. So it connects to so we said curl, let me scroll here to actually so you're trying to connect to HTTP bin/get. So trying to make a request to that URL. So what it does, it first identifies the IP address by resolving that, and then it connects to that on port 80. Port 80 is a port that's used for HTTP by default, and then it sends all those texts that we have seen above there, and then it gets this response back. So if you see in HTTP, and that's all that happens. Okay, there's nothing more that happens when you send any request. Okay, so when you type something in a browser, this is all that happens. So it writes those 4 lines to the server, and server responds with these 10 lines, and so the browser displays it what is there. So if you see what is the client is sending there, the first line, the get, that's HTTP method, followed by the URL that you are trying to request, followed by the HTTP version, and a set of key value pairs, name value pairs indicating the headers. So what's a host, user agent, and then what all it accepts and all that. And the server responds back saying that 200 OK, that means success, and these are all the headers that are there. So so now can we actually send a request by hand? Okay, just to get a feel of what goes behind the scenes. Okay, so let's do one thing. What I'm going to do is netcat -c basically sends carriage return line feed. So /r/n character for every new line. So that is good. So HTTP bin.org is the site that you want to connect, and port 80. Okay, we want to say get HTTP what? Okay, and you have to say host, what host you want to connect to. You can give any headers that you want, but there are some headers have meaning. For example, I want the connection to be closed after this is, oops, it's typo, but let's see if that, okay. If say connection close, that close the connection. Server responds back saying that 200 OK. So it responds back with all this information. Okay. So, see, I started at 11:10. I started at 11:10. It's 11:30. So anyway, so So that's how how this thing work. Okay. Now let's try to understand how actually the browser work, right? So we're seeing how to send a request to a server, but can we actually? So we try to play a role of a client here, right? So trying to see connect to the server and see how the server responds back. Now, can we actually play the role of a server? Okay. So the nice thing about NC is you can actually listen at any port. Okay. So let's listen at port 8000 here. Now what's happening is now the program here is actually the server. Now let's go to our browser and say 8000. Let's connect to 8000. So browser actually sends a request to us. So browser sends a request to our server. Okay. Did you see that? So now we run a program. NC is basically a versatile program that takes your input and then you basically puts you in the loop so that you can respond back as a server. As okay. Now you want to respond back saying that hello world. Okay. So what you need to do is the server responds back with that's a version number, status code, followed by you can have content type text/plain. Okay, and then just followed by hello world. Okay, let's see what the browser is doing. Browser got the hello world. You see that? So what we're doing is basically playing the role of a server, trying to see what happens when a browser requests it. So browser sends a request to a program, which happened to be NC, and it sent all the headers here. Okay, so if you look at the headers, that's a host name, and then the connection keep alive, user agent, what's a browser that's actually sending us a request, and then it can accept HTML and blah blah blah, all the other things, etc. etc. Okay, so the only communication between the browser and the server is just through these headers. There's nothing more. Okay. Okay, so it actually says HTTP 1.1. So it says client says that it can understand HTTP 1.1.
The server should also understand, right, that it can take HTTP queries.
Yes, I'll stop in time. Yeah. Is that fine?
Yeah, browser knows HTTP.
Yeah.
This NC-8000, this should also understand.
No, so no, NC doesn't understand that. NC is basically a program that is a socket program. Now it gets whatever it gets, it just displays it. It doesn't do anything more. It's up to us to. So you can actually start an email program there as well. Okay.
So the server actually responds with something. So that's a program running on that port 8000. You connected to that port and send some message. Now it's up to the client. So the server responded something. It's up to the client now to whether it understands what is happening, what that message is or not.
Now the question is here, okay, how the server can identify this request coming at port 8000 HTTP or something, or will listen all the incoming requests from
No. So the server. So when you write any socket program, the program listens at any port. Okay. So what happens is any request coming to that port is given to that program. Okay. Yeah, I'm taking questions in line, so can I like take all the time? Yeah, thanks. Sure. So that's how the web works. Okay, so when you send a browser, that's all really happens. Okay, is that clear? Right, there's nothing fancy happening. The browser sends is like 10 lines of text, and then server responds back with those 10 lines of text back, and then the browser interprets that based on the headers that are there. Okay, I said content type as text/plain, so it responded back as a plain text. If I say text/HTML, it will actually show it as bold. Okay, for example, if I reload the page again, so that won't work. Okay, I reload the page again. So, sorry. Okay, that's sent here now. So it's HTTP/1.1 200. Okay, and then say content type text/HTML. And here if I say it actually shows it as HTML as bold. So it looks at the content type. So it basically looks at all the headers and then decides how to represent that and what to do with the data. So HTTP is really very simple protocol. The beauty of the World Wide Web is in the simple protocol. So all information that it needs to send is either part of the request headers or the response headers. There's nothing more. Okay. HTTP is stateless. What does it mean is the server doesn't really remember who you are. Every time you come and say, shake hand and say, hey, I'm so and so, you can't say, hey, I seen you like 10 days ago. Server doesn't really remember anything, doesn't have any memory. Okay. So all the requests in HTTP are stateless. So you send a request and all the information that you need to send along with it, you have to actually send as part of your request headers, and server responds back and it gives all the information in the response headers. Okay. So that simplicity really makes HTTP more powerful. Okay. And lot of when you use the frameworks, there are a lot of hide all these details and you really don't really understand. For example, if you look at the headers, there is a request header saying that accept encoding zzip. That means the client is telling the server that, hey, I am capable of understanding data that's encoded in zzip. So if you can, please compress the data and send it to me so that I don't have to wait for too long to receive all the things. Okay. It's also saying that accept language. This client can also tell the server that it can actually accept the different languages. For example, it can accept English with 0.8 weight, English GB is basically British English with 0.6, Telugu with weight of 0.4. Okay, so if it only has Hindi and Telugu, not English, then the server would actually respond back with Telugu because that's the most preferred option for the client that I have. Okay, so you can actually do this kind of content negotiation. So all these things, when you look at internationalization or anything like that, all these things actually happen through these things. Okay, is that clear? So there's nothing else in HTTP other than just this plain name value pairs, the headers that part of the request, and then the things that are part of the response. Okay. Now let me quickly. So that's how these things work. Okay. But now how do you write web programs? Okay. Sorry. So when you write a program, so you can write a socket program that will actually read the response, read the request, and then respond back. But that will be too cumbersome. Okay. So what people have done is people have different ways of writing these programs. You write a CJ program or fast CJ. There are different ways of writing these programs without really worrying about the networking parts of it. But then there are multiple ways you can actually run these things. So what people have done is created something called WSGI, which is a Python standard for writing web applications. Okay, so let's look at what WSGI looks like. WSGI. So so this is a sample program. So what it does is in Python, WSGI is a simple Python function that takes an environment and a start response. I'll explain what that is. Okay. So the protocol is in WSGI, you call the start response with the headers and the status code as soon as it is ready, and then you send the response back as a list or iterable. So the idea is without really worrying about the socket networking, what WSGI does is it lets you focus on building your application. So the environment will actually have all the headers that are part of the request, and then start response is basically start sending the response. Okay. Now I basically used a built-in HTTP server part of the standard library to run this. Okay. But if you see, that's all it's actually required to run any web program in Python. Now things becomes complicated because let's say I want to write a simple add program which has two URLs. Slash, which is a home page, and then a home page and a page to add two numbers. Okay. Now I need to actually have two URLs. How do you actually achieve that here? So what you can do is so you end up doing is you take the environment, from the environment you take the path. Okay, that's how it's available, and then if it's slash, do this. If it's a slash add, then do it. If not, say it's 404 not found. Is that clear? So if you look at the bare bones WSGI, what you do is you look at the path variable and then basically make a decision about what to do about it. Okay, but that can get cumbersome because you can have too many URLs and so it starts becoming tricky. Okay, right? But if you actually see, that's how. If you want to start from bare WSGI, that's how you can actually write this kind of web programs. Now, this is where the web frameworks come handy. So what you can do is, can you actually kind of write some tools to simplify this for us. Okay. For example, for lack of time, I thought I'll actually do it right away here, but so what I'll do is, I'm sorry. So let's look at the WSGI add to so here, so see what's happening is it has multiple conditions, etc. So instead of doing that, what web frameworks really help us doing it is will provide some kind of tools to make the job easier. Often what they do is kind of hidden from us. Okay, so let me say add route path func. Okay, so so what I'm doing is keeping a global routes. Okay, and then add route. What it does, it keeps the mapping from path to the function in a global variable, and you can actually have a dispatch. Okay, path. So what you do is for p comma func in routes, if p equal to path, so what you're trying to do here is trying to dispatch based on the path that you're getting. So instead of doing all of it here, you say dispatch the path. Okay. Now yeah. So just put this thing here. Let me explain what I'm doing here. So what I'm trying to do here is, if you actually find the path that you're looking for, you send it 200 OK and then call that function. Otherwise, you say it's not found. And then you have all these URLs here. There are two URLs here. So you can, what you can do is add route slash will be render home, and add route to slash add will actually go to. So what you're doing is, instead of actually having that kind of conditions there, you basically write your function and then have the kind of routing specified, so that the library can take care of those things. So that's what typically a web framework that you use would actually help you doing it. Okay, so let's try running this now. Oops, I didn't actually add the other one, so let me add. So we're not calling the sorry. So what we're doing is basically starting an HTTP server at the end of it. So let me run this. Oops. Oops. I guess. Okay. So let me run with GUnicorn. So that's under I'm running and activating my virtual env, which actually has that. Okay. GUnicorn WSGI add that's a web server that actually runs that. Okay, so that starts running on this port. So if I look at here, curl, oops, something went wrong. Sorry, I guess missed something here. Dispatch should actually need the start response. Sorry for that. Okay, so I guess let's pass the functions actually here. So what I'm trying to do here is see if we can actually build a simple web framework that we can actually use in our application. Okay. I'm sorry. I guess this is we're almost done. Okay. The function actually gets in run. Okay. Let me explain what I did. So what I'm trying to do is instead of really worrying about how to do if conditions and all that dispatching manually. So this is, let's say this is your application program. You write your functions and then specify the routes, and then that should take care of routing it appropriately. So still something wrong. I guess I'm. Sorry, I'm returning it here, right? Already. Oh, I'm sorry. Yeah. Thanks for that. Sure. Yeah. So home page is form will come here. When you look at the add function here, what we're doing is it says it gives the result. So /add that says the result is 42. Okay, so we basically have some kind of web framework which you specify the routes like that, and then that takes care of running it. Okay, so if you just for completeness sake, examples dot. So you could actually have so I have a small simple web framework which is written just to show how that thing actually works in the examples repository and HTTP bottom up. Okay, so that's how yeah, so that's how things work behind the scenes. Okay, so let me summarize what I've said. So the internet and World Wide Web, they are completely different things. The World Wide Web, internet talks about the networking and the sockets, and World Wide Web really talks about the HTTP protocol, URLs, and all that. And we have seen how that actually works behind the scenes. The important thing to remember is in HTTP, everything is plain text protocol. Server, the client sends everything as part of headers, and server responds back as part of the response headers. And play around with it. Look at the headers, try sending requests by hand, and see what happens behind the scenes. Hope that gave an insights about what happens behind the scenes of your web framework. Thank you. Sorry, I guess I overshot by like a couple of minutes.
Yeah.
Are you okay? I'm okay in time.
Is it okay if we do it often?
No questions now. I'm done.
Okay.
I'm done.
Do it,
Yeah,
okay.
I'm done. Yeah.
All right. Thank you, Anand, for
Sorry,
the exciting talk. Now we have Navarun Pal for the next talk.